chapter is devoted primarily to analysis and design of spur and helical gears to resist bending failure of the teeth as well as pitting failure of tooth surfaces. This chapter is devoted primarily to analysis and design of spur and helical gears to resist bending failure of the teeth as well as pitting failure of tooth surfaces. Failure by bending will occur when the significant tooth stress equals or exceeds either the yield strength or the bending endurance strength. A surface failure occurs when the significant stress A surface failure occurs when the significant contact stress equals or exceeds the surface endurance strength. The first two sections present a little of the history of the analysis from which current methodology developed. Mechanical engineering design, spur and helical gears. The American Gear Manufacturers Association, AGMA, has for many years been the responsible authority for the dissemination of knowledge pertaining to the design and analysis of gearing. The methods this organization presents are in general use in the United States when strength and wear are primary considerations. In view of this fact, it is important that the AGMA approach to the subject be presented here. The general AGMA approach requires a great many charts and graphs, too many for a single chapter in this book. We have omitted many of these here by choosing a single pressure angle and by using only full depth teeth. This simplification reduces the complexity, but it does not prevent the development of a basic understanding of the approach. Furthermore, the simplification makes possible better development of the fundamentals and hence should constitute an ideal introduction to the use of the general AGMA method. Sections 14.1 and 14.2 are elementary and serve as an examination of the foundations of the AGMA method. Table 14.1 is large AGMA nomenclature. Period. The Lewis bending equation. Wilfred Lewis introduced an equation for estimating the bending stress in gear teeth in which the tooth form entered into the formulation. The equation, announced in 1892, still remains a basis for most gear design today. To derive the basic Lewis equation, refer to figure 14.1a, which shows a rectangular cantilever beam of cross-sectional dimensions f and t, having a length L and a load Wt, uniformly distributed across the face with f. The section modulus I/c is ft squared / 6, and therefore the bending stress is stress equals m divided by I/c equals 6w t L divided by ft squared, t being an exponent of w. Gear designers denote the components of gear tooth forces as W, T, an exponent denominator, below W exponent, WT, WR, WA, or WT, WR, WA interchangeably, with WT, WR, WA, the latter having exponents TR and A, and the former bottom exponents TR and A with W. The latter notation leaves room for a post subscripts essential to free body diagrams. For instance, for gears 2 and 3 in mesh, WT exponent 23 below is the transmitted force of body 2 on body 3, and WT 32 below T, T an exponent of W, 32 in W T 32 is the transmitted force of body 3 on body 2. Table 14.1 symbols their names and locations. C E mesh alignment correction factor. CFZR surface condition factor. CHZW hardness ratio factor. CHZW C M A. Mesh alignment factor, CMC load correction factor, CMF face load distribution factor, CPZE elastic coefficient, CPF pinion proportion factor, CPM pinion proportion modifier, D pitch diameter, DP pitch diameter pinion, DG pitch diameter gear, F parenthesis B parenthesis net face width of narrowest member, FP pinion surface finish, H power, HB Bernal hardness, HBG Bernal hardness of gear, HBP Bernal hardness of pinion, HP horsepower, HT gear tooth hole depth, I parenthesis Z I parenthesis geometry factor of pitting resistance, J parenthesis YJ parenthesis geometry factor for bending strength, KB rim thickness factor, KF fatigue stress concentration factor, KM parenthesis KH parenthesis load distribution factor, K circle overload factor, KRYZ, K R parenthesis Y Z parenthesis reliability factor, KS size factor, KTY circle slash parenthesis temperature factor, KV dynamic factor, M module, MB backup ratio, MF face contact ratio, MG gear ratio never less than 1, MN load sharing ratio, MT transverse module, N number of stress cycles, NG number of teeth on gear, NP number of teeth on pinion, lowercase n speed in reverberations a minute, R E V slash M I N rev minute. The end.